Welcome everyone. Again, my name is Pratik Agarwal. So let's get started with the part 3, session 3 of Introduction to SQL webinar series that I've been running for last month or so. Again, thanks for attending the session. The session would be, I'll try to keep my session very, very objective and to the point. And I'll take questions. Should you have any questions, you can always interrupt me and I'll try to address those questions right away. In the last two sessions, in the last two introduction to SQL webinar sessions, we have covered some of the basics, introduction to why we use SQL, what it is, and then we also did in the last part 2 webinar, which you can view on our YouTube channel. We did cover some basic functions in SQL, and we also had done pattern matching using like operator and so on and so forth. So today our focus would be on understanding how do we do intersection difference comparison between two tables or data sets in SQL. We'll also do grouping, clustering in SQL. Then we'll also see how we can order or sort the data using select queries. And then if time permits, then we're going to do the last two items in the agenda as well, which is top or row num clause, which is used to extract few records, especially very useful when you're working with large amount of data. And then lastly, we'll see some text functions if time permits. The last two items would be if time permits. Okay. Just quickly going back to the conference. I hope good. So everyone can hear me clearly. Great. All right. So the data that I'm going to be using for today's webinar would be similar to the data that we have used in the past as well. I'm going to use primarily I'm going to use this table called a student table, which has a structure like this. It has got student ID in it, student full name, date of birth, sex or gender, class, which class a particular student belongs to. H code is house code, red, blue, green, yellow. D code is the district code that a student comes from. Remission is a Boolean yes/no field, whether or not a student has paid the fees or not. M-test is a mathematics test code, and P-test is a physics test code. So these are the fields that we have in our student table. Now, the database that I'm using to illustrate some of the basic operation of SQL in this session is MS Access, but I could have used any other database, but I decided to use MS Access because it's easier to teach upon. Now, I'm going to go to the SQL view. Now, SQL view, as I told in my last session as well, is hidden in MS Access. So I go to Create, and then I click on Query Design here, and then the Show Table option will come. I close this, and then there is SQL view here. So I select the SQL view. Again, I'm going to explain this step again very quickly. Create, Query Design, close the Show Table option, and then SQL view. Okay. Now here, if you remember from my last webinars, the basic construct of select statement, which is used for querying objects from the table, is select, from, and where. Right? This is a very, very basic construct. Where is optional here. Unless you have a condition, you won't write where. Now, so the first thing that I want to explain to you here is intersection. Okay. Now, what exactly is intersection? Now, let me open my class running nodes on intersection, which is here. Now, say for example, if you have two sets of data. Suppose set 1 has these data, these elements, and set 2 has these elements. Then the intersection between set 1 and set 2 would be the elements which are found common in both the sets. So that's what I'm trying to represent. This operation is what I'm trying to simulate in SQL. So we will use an operator. We'll use a comparative operator called as in here. So look at this small SQL command. From student where ID in 1358, select full name. So what is happening in this query is that from the student table, it will display only those full names of the students who have IDs falling in this set 1358. If you were to expand this, say we could have also done the same thing using multiple OR statements. How? From student where ID is equal to 1, or ID is equal to 3, or ID is equal to 5, or ID is equal to 8. So we could have done the same thing using multiple OR statements as well, but that could have been very, very cumbersome. Plus, if you're working with data across two different tables or multiple tables, then in statement becomes your only choice for finding intersection like this, right? or inner join that we'll discuss in the later webinars. So that's how it will work out, right? Now, opposite of in is not in. If in gives us intersection, then not in gives us difference. How? From student where ID not in 1358, select full name. So this will give you the difference. That means the students, the names of the students who do not have ID falling in this set. So that is what this is going to display, right? But the real power of in statement is when you are working with multiple tables. Say for example, we have got two tables called as publisher table and books table, right? Now in the books table, we have we have foreign key PID which links us to the publisher table, right? PID is the publisher ID of a particular book that is getting published, right? So imagine that each row in the books table represents one book, right? And one of the fields in the books table, one of the columns in the books table is PID, which connects the books table to the publisher table, right? So suppose if you want to know the publisher details of a particular book, right? So if you know the book name, say for example, book name is Babylon, right? So if you know the book's name, you will first find out the PID associated with it. Now obviously in the books table, we won't have all the publisher details except for the PID, which is the publisher ID. Now using that PID, I'll go to the publisher table and I'll fetch all the publisher details relevant to or related to that particular PID. So that is what is going on in this query here. Now what is happening here is, since you see books table is a different table from the publisher table. So from publisher where pub ID in, select PID from books where title is going to Babylon. So when we write nested query like this, or query inside another query, or sub query like this, the inner query gets executed first. So if you look at the inner query here, what is happening here is from books, the books table will open here where title is going to Babylon. So whatever rows that were matching, that means in whichever rows where we had title field as Babylon, those rows will be selected, and for those rows, what field will be selected? The PIDs, right? So suppose you see, if multiple publisher can publish the same book, say for example, if that is possible, then you would have all those PIDs. That means all the publisher IDs who have published a book called as Babylon, right? So those would be selected, right? And then this query, say for example, if you look at here, then this query will resolve or will become very similar query to the first query that we have spoken about in the intersection. So from publisher where pub ID in, then all the PIDs associated with which publisher? Associated with the title Babylon, right? So these are all the PIDs of those guys. And then we are doing a comparison using an operator, pub ID in this set, right? So this query will display all the pub ID and the publisher, all the other details. You want to know about pub name, email, address, whatever you want to know about the publisher, you can fetch from the publisher details, publisher table from this query. So the idea is when you're working with multiple tables and you want to fetch information which are common across two tables on a particular column, like here, the common column was PID was mapped with pub ID, right? So that was the common column which was connecting the two tables. So on the basis of common column, if you want to fetch information from multiple tables, using in becomes very, very handy then, right? So you see, in can also be used for different data types. So for example, select DOB, which is date of birth, from cricket table where full name in Peter, Sam and Tina. So what is happening is, it will display all the date of birth of students or, people who are playing cricket, okay, who are these guys? So Peter, Sam and Tina. So these are the three guys for whom this query will print the date of birth. So that's how it's going to work out, right? So it's a very simple, fairly simple query, which is pretty helpful. Now let me demonstrate that in Access or in SQL. Say for example, we got in the let me show you the query that I'm going to do. So first example that I'm going to execute in SQL using in is, find the students who have IDs in the following set. What are the IDs? Students who have IDs in the following set. Which set? 1, 5 and 9, right? So from my students table, I want to print only those students who have IDs 1, 5 and 9, right? So select from student where ID in, right? I write 158. You don't even have to give spaces the way I've given, but it just makes the query look beautiful. So select, suppose ID full name, right? So now if I want to run this query, I go to design here and I click on run here. Now if you notice, we got the ID and the name of the students, right? 159, right? Now if I go back to my SQL command, I can right click here and I can go back to my SQL command. Should I want to save this query, I can again save this query by right clicking here and save, say for example, 159 in. This is the name that I want to give to this. So this query got saved here, right? Now let's look at the second example. This is the names of the students who are playing a musical instrument. So hint is refer to music table, music and student tables both, right? Names of the students who are playing a musical instrument. So here you have to understand that we want to print the names, right? Playing a musical instrument. So names we are going to get from the students table. And if you notice here, we got one more table in this database called as music table. And in the music table, what do we have is the first column is the student ID and the second column is the type of musical instrument a particular student is playing. But in the music table, we do not have any other detail about the student, right? In the student table, we have got all the details about the students, but no details about the music table, right? So what we want to do is we want to find the intersection. That means we want to find the common IDs between the two tables and then we want to print the corresponding full names. So that is the goal that we have. So I'm going to go and create one more query here, query design, right? And then I write from student, right, where ID in, select ID from music, right? And then for those students, I want to print their full name, right? ID and full name. So these are the 9 students and their names, ID and their names, who are playing some musical instrument, right? So that's what is happening here, right? Now, some people might be wondering, can we print the type of the musical instrument someone is playing? So the answer is, using in, you can print only the information. So this, if you try to print type here, which is present in the music table, right? Which is present in the music table. If you try to print that, then you'll get an error, you'll ask for a parameter value type, which means the SQL compiler is not able to find type column in the table, in the source table. Here the source table is student table. Here the source table is not the music table, whereas type column is only present in the music table. And the life of this query ends here, right? And this query will be replaced with the ID from the music table, right? So what is happening here is that you cannot, with the in statement here, you can print information from outermost table. From the outermost query, whichever table that is present in the outermost query, you can print information from only that particular table, not from any of the innermost tables. Although you can find intersection, but you cannot print it. Not using in statement like this. That we can do using inner join or intersection join that we'll discuss later on, right? So here you cannot print any of the columns from the music table, right? So that is what it is giving you here. So that is how this question would be done. Now the third question is, list the students who are born on Wednesdays or Thursdays. Now here, basically, if you look at the student table here, what do we have is, we have here date of birth, but we do not have the day of the week a particular student was born. So we'll have to do that translation work. We'll have to figure out from the date of birth of a particular student, we have to extract the weekday as well. Now there is a function called as a weekday function. So I'm going to save this query and then I'm going to create another one. This query was students from music table, right? Again, so my here is, list the students who are born on Wednesdays or Thursdays. So from student, now the question is the date of birth we want to check. So there is a function called as weekday. Weekday function. What weekday function does is, if you provide any date to this function as an argument, suppose if I provide date of birth to this function as an argument, what it does is, suppose, you know what, just to display it, I'm going to show it to you. Say ID, full name, and date of birth, and then here I'm doing this as detail, right? So this function, what this will do is, if I run it, what it is doing is that weekday function is extracting the day of the week on which this date fell upon. So 4, by default, what happens is your counting, your count starts for weekday. The count starts with Sunday. So your Sunday is 1 and your Saturday is 7. So if it is 4, that means it is Sunday, Monday, Tuesday, Wednesday, right? If it is 6, that means it is Friday, right? If it is 2, then that means it is Monday, right? I mean, it also depends as to, while installing MS Access on your machine, what is the default calendar that you're following. If you're following Sunday being 7th day of the week, then, the calculation would be like that, okay? Or Sunday being 1st day of the week, then the calculation would be different, right? So that's how weekday function works. Now, we can use this function in the condition because we want to filter only students who are born on Wednesdays or Thursdays. So weekday DOB in 4, 7. Why 4, 7? Because we said, okay, Wednesday or Thursday, right? So 4, 5. Because, 4 represents Wednesday and 5 represents Thursday. And we are saying or, so we can always use in here, right? Because in can also be used as multiple or statement, right? So this will convert this weekday DOB, extract the day of the week, and then we are comparing with this set here, right? Then this will display only those students who have their birthday falling upon 4th day of the week and 5th day of the week, which are Wednesdays and Thursdays respectively, right? So that's how it can work. Then if you do this question, list the students who are not born in January, March, and June. January, March, and June. So what I'm going to do is I'm going to modify this query itself. Overwrite on this. Select from student where now here there are two functions. There are we'll use another function called as month. So what month function does is month extracts the month out of any date, right? So it will extract the month out of this date here. So that is what it is doing. For every date, it is extracting the month. So you can see that it is extracting the month out of every date. Now, if the question, students who are not born in January, March, and June, so where month of DOB, not in, this time we'll use not in January, March, and June, not in this segment, in this set. So it's showing you all the students who are born other than in January, March, and June, right? So that's how it is working. So that's how in operator works, very handy if you want to find the in and not in, actually if you want to find the intersection and difference. Now the next thing that we want to do today is grouping. Now grouping is fairly important concept in SQL. Now I'm going to go back to my class running notes here. Yeah, grouping. Now say for example, now where do we use grouping? Where is it applicable? Say if you look at this question here, look at this query here, from student group by class, select class, count of class as CNT. So what is happening here is that from the student table, it will make clusters based on the class column. So if there are multiple students coming from different classes like this, say for example, if you look at this data here, right? So multiple students must be coming from the same class or must be going to the same class. So class 1A has say 4 students, class 1B has 3 and class 1C has 3. So what is happening is from the student table, it is grouping by the class column and it is displaying you the number of students in each of the classes, right? So that's how it is working. And so, say for example, I create a new query here. Now, say select from students. If I do group by class, right? And if I want to see how many number of students are there in each of the classes, how many number of students are there in each of the classes. So class, comma. Now I'm using another function called as count of class. So count of class, you see this is an aggregate function, group function. So the moment you do count of class, and before that if you have grouped already, so for every group, so that means for every cluster, it will give you the number of cells which are there in every cluster, which have value for class, right? So as CHC, so class, count of class, right? 1A, number 6, 1B, 4, 1C, 2, right? That's how it is working. Okay, group by class. If you wouldn't have done grouping by class, and if you would have printed only count class as CNT class, so it would have given you all the students who have a value for class column, right? Now you need to be a little careful while working with the group, by the way. Suppose you want to know the number of, you want to know the total number of students coming from each district. And that is the question that you want to find answer for. So here, grouping would be done by which column? See here the district column is in the student table. District column is D code, right? So the grouping would be done by D code from student group by D code, and then here D code, comma, count of D code, right, as say SCNP D code. This cannot be right. So again, if I run this query here, so for every district, the number of students who are coming from each of these districts is being shown here, right? Now, what you need to be careful about is, say for example, if you're tempted to print full name, right? D code, comma, full name, comma, count of D star. Will it run? No. It will give you a syntax error. It will give you an error saying your query does not include the specified expression full name as part of an aggregate function. You see, this, what we're trying to do here is logically wrong. Why is it logically wrong? Because we have grouped them. What have we grouped them by? We have grouped them by D code, right? So now if there are multiple students in each of these groups, right? And so, you can perform arithmetic operations on it. You can find average, count, those kind of sum or max or min. But the moment you try to print each one of those cells in each of the groups, then, there is no logic of grouping them. So that is why you cannot print any column which is not part of the group. See, we were able to print D code here though. Why? Because we had grouped by D code. So as long as you're printing, as long as you're, using D code in your select query, it is fine. Okay, because that was the column on which we grouped it by, right? And for any other column, you cannot print it. You cannot even print, say, gender or class. I mean, none of these columns can be printed unless they are grouped as well. So here, I mean, just like count is one of the group functions, there are other functions like AVG of MTest. Say, for example, you want to find the average mathematics test score of students coming from each district, as well as average physics test scores, as average maths, and as average physics. Now here what is happening is for each of these districts, we are showing the number of students, plus also we are showing the average maths and average physics test scores. Okay. That's how grouping is working here, right? Now, say for example, I'm going to suppose if the question is find the average math test score of girls in each class. If that is the question, right? Girls in each class. So from student, now here we'll use a where clause to filter the boys out, right? So where next we will do only females. So all the boys will be filtered out, and then we are grouping by which column? We are grouping by class column. Then here it is same as before. You will print class, and then you will print AVG of M test, right? So now it gives you the 1A for every class, the average of girl students, right? Right? Becomes a little more meaningful. Now, say for example, you do not want to show so many decimal places of accuracy, right? You want to restrict to 2 decimal places of accuracy, or 1 for that matter. So you can always use a round function here, round up this to 1 decimal place. So now this is rounded up to 1 decimal place. So that's how you can quickly use it. Not very difficult, right? Right. Now let's do some questions which I had in the slide on grouping. Let's do some group related questions. List the number of girl students of each district. We have already done that. List the max and min test score of class 1 students of each district. List the max and min test score of class 1 students of each district. So select from student, group by of each district. So the code, each class. We are doing the second question. List the max and min test score of class 1 students of each district. So the code, but it said class 1 students, right? So how do we filter class 1 students? So if you remember, like from our last webinar, so where class like 1 or question mark or 1 star, if you're confident that it won't go beyond 2 characters. And we want to show the max, so max of and test, min of test. So it is showing you the D code, the maximum mathematics test and the minimum mathematics test. So that's how it is working. So here this was the only twist. Let's do some more queries. List the average math test score of the boys in each class. Now this question, list the average math test score of the boys in each class, is very simple. Here, so we need to replace the filter first. Let me get rid of this. So where next we will do N, average math test score of the boys in each class. So grouping should be done by class, and then class AVG mathematics as AVG boys maths, right? So this will give us class-wise average mathematics test score of the boys student. However, there is second part to this. I'm on question number 3. The list should not contain class with less than 3 boys. The list should not contain class with less than 3 boys. Now what is happening is, there is one more condition. The condition is that the count of class, right? That means the number of rows in the class in each of these clusters, which are each of the groups of class, should not be less than 3 boys. Now see, this is a group condition. Now, so the condition here is, we'll be tempted to write the condition like this: count of class should be greater than with less than 3 boys. Should be greater than, the list should not contain class with less than 3 boys, right? So we'll be tempted to write it like this. So we'll be tempted to write that count of class should be greater than 3 as part of the where condition itself. But if you look at the execution sequence, you see the execution sequence is what? First, I go back to my Excel sheet here. In a group SQL query, the first statement that gets executed is from. Then if there is a where, then where will get executed. Then it comes to grouping. Then it goes to select, right? Now what is happening is, the moment you write count of class before you have grouped it, so you will get an error saying cannot have aggregate function in where clause, right? Because we have not even grouped it. So you cannot have it on the where any aggregate function, any group function like count, sum, average, max, min, or any of these group functions in SQL cannot be put as part of the where condition. For such conditions which involves aggregate function, we have one more condition statement which is called as having. Okay. Having is exclusively used for writing conditions which involve aggregate functions, which involve group functions, right? So we are saying from student where succeed to m, that means we will filter out all the female students, group by which column? Group by class column. And what is the group condition? What is the aggregate condition we are putting here? We are putting the fact that having count class greater than 3, right? Well, we did not have it, but say for example, if I reverse it, say it should be less than equal to less than 3. So then we will have a 3, right? So that's how it's going to work out, right? So this query highlights the importance of using having, and how do we use having in SQL, right? So from student where success to m, group by class having count of class less than equal to less than 3, not less than equal to 3, right? And remember, there is a difference between where and having. Where is used at the row level and to write conditions at the row level, and having is used to write conditions at the group level. And having will always involve one of the group aggregate functions as part of the condition, right? So that is the difference between where and having. Very common question asked during the interviews as well. Okay? Alright guys, so let's do a topic which is ordering, or which is called as sorting, right? Now if you look at this, now sorting is a very simple concept. We normally sort the data in ascending or descending order, right? So that's what we are going to do here. So look at this. From student where S name, like whatever that is, order by class column descending, S name, that means student name ascending, right? So what would happen is, in the output, it will display the output sorted by the class column in a descending, decreasing, alphabetically descending order, and within the same class, there could be multiple students, right? There will be multiple students. So for those multiple students within the same class, if, say for example, class 1A has 5 students, so within 1A class, those 5 students' name would be displayed in ascending order, right? So that's what, so ordering is always done in a hierarchical manner. So since we wrote class first before S name, so first level of ordering would be done by class column, then second level of ordering will be done by student name column. Okay, you can have n number of columns here. Okay, similar to this is from student order by decode descending. Now, if you do not write DSC or ASC, that means if you do not mention DSC or ASC at all, then it is by default ascending, increasing, ascending order. So order by decode descending, class ascending, full name ascending, right? So within the same district, there could be multiple students coming from the same class as well. right? So within the same district, so if you look at this example here, within the same district, so SMT, 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 there are multiple students coming from the same class. So SMT, 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 the first level of first level of sorting is done at the group at the decode level. So SMT, 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 and HJJ, HJJ. That means it's descending and decreasing order, right? Alphabetically descending order. And then within SMT, if there are multiple students coming from the same class, like this here, right? So then here, what is happening is 1A, 1A, 1B, and then 1C. And then 1A is getting reset because that's now part of the different decode, right? So, and the other thing that we notice here is, within SMT, within the same district, there are multiple students from the same class as well. Now, the third level of hierarchy says that full name should be sorted in ascending order, increasing. So, SSS and then TTT. Then within the same district but different class, then E could come, 1C, A could also come, right? Ascending, increasing from A to Z. So that's how multi-level ordering works, or multi-level sorting works. Now, if you look at this example here, from student, order by one descending. One descending meaning after the select statement, in the sequence that you have written, right? So this is the sequence that it takes. One descending means the first column after the select statement, which is decode. So decode descending, comma 2, which is class, comma 3, which is full name, ascending, right? So which is, this query is exactly same as this query. It's going to do exactly the same operation as this query. It's just that instead of writing the specific column names here, we are writing their sequence number in the ordering, right? The execution sequence of ordering is a little different. You see, whenever you are using ordering has to be the last clause that you write in the SQL command, because ordering gets executed at the very, very end, even after select, right? So ordering will get executed after the entire statement has executed, okay? And that's how it works. Now, if we go to the ordering here, list the boys of class 1A sorted by their names. List the boys of class 1A. I'm on question number 4. Boys of 1A sorted by their names. If I were to do this question here, so select from student, right? There is a condition here as well, where boys, right? So select to do M and class we will do 1A, right? And then we are writing, we want to print, say for example, we want to print their ID, full name, gender, and class. And now we want to do ordering. Now if you want to do ordering by sorted by their names, so order by full name. Now in the question it was not mentioned whether you want to do it in ascending or descending. If you want to do ascending, you can write ASC, or you can just leave it. By default it will be ascending. Or if you want to do descending, Z to A, then, or Z to A, then you have to write DSC, and then when you run it, so since it is sorted by full name in decreasing order, so P, then M, then J. So that's how it is shown in here, right? So very easy. Now I'm go to question number 6. List the number of students of each district. Sorry for that typo. List the number of students of each district in descending order. Now see, what is happening is, in the question number 6 is the combination of grouping and ordering. List the number of students of each district. This we will get by doing grouping, right? And then whatever the output is, then we will sort it in descending order by the number of, right? So I go to the SQL view and I overwrite on the same query. Select from student, group by decode, right? And suppose I want to print decode, count of decode as CMC decode, right? Now, what we want to do is, we want to order by, say, count of decode in, suppose, descending order. So what would happen is showing you decode and the number of students coming from each of the district code, but we have sorted it by the number of students coming from each district, right? In descending order, decreasing order. So that is what is happening here, right? Decode and the decreasing order of count, right? So the question can be confusing. List the number of students of each district, okay? So here first we have grouping and then we are ordering. Now look at the question number 7. List the boys of each house sorted by the classes. List the boys of each house sorted by the classes. Now this could be confusing because it sounds like grouping, but it's not exactly grouping. It's only ordering. Why? Because we want to list the names of the boys as well. List the boys of each house sorted by the classes. So ordering meaning there are two columns that will be ordering here. List the boys of each house sorted by the classes. So where gender is equal to male, and then suppose full name we print H code class full name, and now we want to order by H code. Suppose I want to order by H code, then I want to order by class, then I want to order by full name. So first level of hierarchy is first ordering will be done by H code in ascending order since we did not mention anything. So BGR. Now within G there are multiple students coming, right? Say 1A, 1B. So now the second level ordering is happening in the class column here, and the third is happening here. So that's how it is working. So this is called as multi-level ordering. So as you can see, ordering is sorting in SQL is fairly simple. Only thing that you need to remember is that do not get confused between ordering and grouping, right? If you want to print the names or if you want to print the data, complete data, then you would go with ordering. But if you want to just do some computation calculations at the group level, then you would go with grouping. Alright guys, so time's over for today's webinar, but in the next webinar I'm going to cover the rest of the topics which were remaining in this webinar. So these are the two topics which I couldn't cover today, top and text functions, but we covered intersection and difference using in and not in. Then we also covered grouping, which is a very important concept, very useful concept. And then we also discussed a simple concept, sorting, ordering, right? So these are the three things that we discussed. This video will be uploaded onto our YouTube channel. Now I open the floor for questions. Should you have any questions, I'm willing to take them. Any questions, guys? Feel free to ask. All right, guys. Thank you then, everyone.